logarithmic function, exponential function, and chain rule under the basis of our differentiation. Now, in our early classes, we might have discussed about exponential forms and logarithmic forms of expressing mathematical equation. And for some of us who actually are not so good in mathematics, I'll give us some introduction to logarithmic functions and some properties we need to keep in mind. Now, majorly in mathematics class, if we have a is equals to b to the power of c, this is called an exponential form of equation. Exponential form. This can also be expressed in logarithmic form by saying log a to the base b is equals to c. The logic here of changing exponential form of equation to logarithmic form of equation is very, very important in mathematics class. This is called the logarithmic form. Logarithmic form. And this is the definition you give to your exponent, which is indices and as well as log. Now, the base here is equals to what? Is always raised to the power of the right hand side, and the a here is called the argument in what? In mathematics. So far we are only trying to talk about the basis. I only want students to know that what exponential form can be converted to logarithmic form and vice versa, which you need to keep in mind as you move forward in what, because here in physics we are going to use this one very, very well when we are talking about derivation of formulas and other things under physics. Now, another type of logarithmic function we can also keep in mind is another special type of logarithmic function you might have also discussed in your mathematics class. We call the natural log. Now, about the natural log, it is denoted by what we call the ln. ln. So now, when you say ln of what? Of any function, it is called natural log, and it is just expressed in a simple way. It simply means the log of a number, or log of any values to base e, to base of e. So that is what we call natural log. And e, you see, when you press on calculator, I said it's going to give you a value like 2.71, and e is called exponent value. Exponent value. So these are elementary, or the basis you might have studied before in your early classes, so you always have to keep it in mind. So if I have examples, y is equals to e to the power of x. Now, as I have said here, this can also be expressed in form of logarithmic form as log, as you can see log y, because the argument here is y, the base here is e, and what the answer to that is equals to x. So this is the logarithmic form, this is the exponential form. So y is to the base of e. Instead of writing it in this form, you can also write this as ln of y is equals to x. So these are basic things you have to keep in mind as we move forward to talk about the differentiation of logarithmic form and exponential form. I'm trying to bring in some things you might have learned in your mathematics class. You always keep in mind when the log is base is e, it is always taken as natural log of that particular thing. So this is the way we are actually talked about that. And some other thing I think you might have also learned in your standard class is talking about the standard properties of log. So let's just look into some properties of log before we go to the differentiation. So early classes, you might have studied that if you have log in product form to the base of 10, let's just take that, is the same thing as log a base 10 plus log b base 10. I hope students still remember this. Whenever log are in product of each other, you can take each of them, and what connects them together is nothing but the addition. Another one is when you have log, let's take a by b as the argument to the base of 10, is the same thing as saying log A to the base of 10 minus log B to the base of 10. That is the second property. Another property I think I should talk about, which you can keep in mind because it's very important, is when we have log, argument in this case is A to the power of B, base of 10. The law states that you can flip this to the other side. It will be B log A to base 10. Very important for this topic. And the last one, which is very, very important, we call the change of base formula, is if we have log A to the base of B, you can change it by saying log A to base of anything, let's say 10 now, divided by log B to the base of 10. So please keep this one in mind, all these four basic properties of log, and please always have it at the back of your mind that when you change base, you can actually put it to any base. It can be log A base E, log B base E, which is natural log of A over natural log of B. So students should keep this in mind because these are just the introduction to logarithmic forms and exponential form. But talking about the main thing of today, which is talking about how to differentiate or the standard parameters we need to keep in mind, talking about differentiation of logarithmic function. Logarithmic functions. So now when we have logarithmic function directly, we only have two situations we use in mathematics and also in physics. In physics, it's just these two that is most important. In mathematics, you can discuss extensively on all these later parts when you get to college. Now, if we have a y is equals to what we are talking about, natural log of x, which is ln of x. So what we call y prime directly when you see that, which is the y dx, is nothing but 1 over x. So next time you see ln of x, which is what we call natural log of x, when we differentiate the direct formula we use is just 1 over x. The second one, which is also important under logarithmic equation or functions, is when you have y is equals to log x base a. This time around it's not base e. If it is base a, it will be natural log of this. But if the base has been changed, direct formula we use for y prime, which is the y ds, is 1 all over x ln of a. So just you can even try to do this using what we have already studied here in change of base here. This is the same as log x base e divided by log a base e, which is the same thing as 1 all over, because you know log of the same base are always equals to 1 over x ln a. So please always keep it in mind because these two formulas are going to be applied directly solving logarithmic function. So what I want you guys to keep in mind here is just direct application of all these formulas of what logarithmic function is very, very important. The next one is exponential, differential of exponential function. The same thing is also applicable. We can only express that in two forms, and when we do that, this is what we're going to have. So now, as you can see, my dear student, we want to take the differentiation of exponential function. Differentiation of exponential function. Now, just as we've already discussed on logarithmic function, we only have two of these two. The first case is if we have y is equals to e to the power of x, then we say the y ds, which is y prime, is still going to be the same, and we write it also as e to the power of x. So exponential form of differentiation remains same when you differentiate it. Now the second way you can also have exponential form is when you have y equals to, if it is not e now, let's take another variable, a to the power of x. Then if you are to get the y ds, which is y prime, it is just the same thing as a to the power of s ln of a. So these are the two forms of differentiation of exponential form. You just need to keep in mind for you to always have a direct answer to most of these questions as it is supposed to be when solving questions. So the next one, which you talk about in this slide, is what we call the chain rule of differentiation, which is one of the most important rules we need to understand very well, because it is going to be useful as we move forward in our concept of physics, because this is the one that I need students to get very, very well. So now let's discuss about chain rule of differentiation. It is just a method we apply. Just listen, students. This is just a method that we apply whenever we have a function in function. So you don't need to disturb yourself by saying which one is chain. So it is a situation whereby we are having more than one function in another function. So we call f, I, f. So whenever there is a function in a function, the practical logic we use is what we call the chain rule of differentiation. So students should keep this in mind, because it's very, very important for us to know this as we move forward under this topic. Now, the chain rule of differentiation is just a method we use for function in function as discussed. So how do we apply that? What we just do is that we directly substitute the function of a new variable and differentiating the main variables. So here we don't need to disturb ourselves. We can only get this by carefully looking into some examples. Now we can take some example of function in function question by saying y is equals to, let's take sine open bracket x squared plus 3x plus 5. The examiner asks us to find the y by dx. Now in this question, if you carefully analyze it, we have two functions in function. We have the inner function, which is algebra function, and we have the outer function, which is a trigonometric function. Now if students carefully analyze this, you are going to see that what we have already discussed how to differentiate this, and here we have sine, which is a trigonometric function. Now if you look very carefully, you cannot differentiate. You can differentiate sine to be x, to be cos or sine, but here the functions are inside another function. So this particular second function, which is the inner function, is going to be taken to be another variable. I want students to understand this because it's kind of very easy, and you don't need to be cramming formula to do function in function question, which we call chain. Now to carefully analyze this is what we are going to do. Now what we do is that we look at the inner function, we take it to be equals to another variable. So if this is my inner function, in this case I will say let t, for example, be equals to, I can take any alphabet, I can say let u be equals to the inner function, which is x squared plus 3x plus 5. So here, if t is now equals to this, what I have left in my function is y is now equals to sine. You can see the inner function is now t. We turn this to t. I take y with respect to t. We call it dy dt. From our knowledge of early classes, sine is giving us direct answer, which is cosine t. Then t with respect to s is dt dx. From early classes, algebra form, this is 2x plus 3. So if you carefully analyze this, my dear student, what we need is the y ds. To get the y ds, if I look at this function, this and this, when I multiply the two, you are going to see that the y dt times the t dx, this and this will take out each other, then I will have the y dx. So you don't need to disturb yourself. Multiplying the two answers will give you the value of the y dx. And one last thing, my dear student, is for you not to forget to replace t back to x, as you don't need t in the answer. What you only need is the value of x. So remember to change this because t values was x squared plus 3x plus 5. Then we have, then the answer to this, we are multiplying this times this, is 2x plus 3. So the method we are using here is called function in function, which is called the chain rule. You can always keep in mind. Let's take another one for you to understand very well. If we have an expression of another example to understand this stuff very well, if we say y equals to ln of sine x, the examiner asks you to find the y dx. As you can see, my dear student, yet again, we are having two functions. Inner function is sine x, outside function is natural log of natural log. We have carefully analyzed this before, and the logic is the inner function we are going to make another variable, which you say t. You say t to be the inner function, which is going to be sine x. Then you are left with y is equals to ln of the function of sine x here is now t. What we do is we take y with respect to t, we call the y dt, which is going to give us, remember, ln of a particular function is 1 over that function. When we differentiate, we just discussed that now. Then the t dx, t with respect to x, will give us nothing. This is a trigonometric function. You can do directly. This is going to give you cos x. Remember the logic. What you do is just to multiply the two to get what you need as the y dx. And when you do that, remember to change the value of t back. 1 over value of t here is nothing but sine x multiplied by cos x, and the direct answer here, cos x times 1 is cos x divided by sine x, is going to give you cot x from your trigonometry. So please, my dear student, I just want you to see this, that the method of function in function is very good, and we can also always keep it in mind that this method is very important, especially in the physics, and the reason why we are studying the basis of differentiation and integration. You need to know the function of function very well and not to make mistake when you are dealing with them in classrooms. So please, I will also teach you direct way of getting it whenever you have function in function, not to waste time and not to write it out in paper. So now the direct method is what we want to discuss now, and take more examples so that we can actually have it in mind that we've already gotten how to solve function on function. So let's discuss about the direct method without writing anything down or without writing it out on paper. So about direct method is just by constant practice, my dear student. When you practice more, you are going to get how to get answer to this directly without writing anything on paper. Now let's take some, maybe 4 to 6 examples, if time permits, and solve directly without wasting time. So the first one, using direct method, y is equals to sine open bracket tan x. In this case, we are having two trigonometric functions inside what each other. We are now looking for find the y dx. Now, students should remember, we are not writing anything out than to solve the answer and get to this stage without wasting time. The method we employ is this. Students, just see. So the y dx, which is y prime, will give us nothing but, look at the method. The method is very, very simple. What I do is that the inner function here, I am going to take it as a function of t. We are not writing anything down, so I want you to listen carefully. So here we say t equals to tan x. So what I do is that after making this one t, I have sine t. I am going to differentiate sine t, and then I differentiate sine t, I'm going to have cos t. Remember, I will not put t back in my answer. I will put it in terms of what I have here. So it will be cos t, which is cos tan x, then multiply by, t is equals to tan x, just what we have here. I will differentiate t with respect to x. If I differentiate tan x, I am going to have sec square x, which will be the direct answer to this question. So cos open bracket tan x sec square x is the answer to this question. Don't worry, with constant practice you get it. We can take another one. Let's say y is equals to square root or under root of cos x. The question is find the y dx, which is also being called y prime, or what we call f prime of x. Now here, doing this one directly, the logic is, remember what I have inside the function. I have algebra function and I have trigonometric function, which is cos x. So what I will do here directly is just to remember that in our algebra, this is something as saying square root of x. Remember, square root of x, we've discussed that under our algebra function, that when you have square root, you can say this one is the same as cos x raised to power 1 by 2 anyhow. Now the logic is the function, inner function here is this, so t will be equals to cos x. So I have known that this one, square root of x, is something as 1 all over. So if I look for y prime, look at this, guys, don't make mistake. I will let t to be equals to the inner function, which is cos x. So what I have left will now be equals to square root of x, and direct substitution under algebra formula, square root of x will give you nothing but 1 all over 2 root t, which is cos s. I'm going to change it back to, that is t, which is cos s, will be cos x. Then I multiply by, I will differentiate cos s, which is going to give me negative sine x. So the answer to this directly will now be equals to negative sine x all over 2 root x, 2 root cos x. So students should carefully understand this. It's very simple. I'm following the same method, but here I don't need to write too much. But to understand that we've done 1 over x directly in algebra is negative 1 over x squared. We've talked about 1 square root of x as 1 over 2 root x. So here we have, I'm taking cos s to be t. So if I differentiate root t, I will have 1 over 2 root t. Remember, I don't repeat t. T will be the function which I will put there as cos s. Then I will differentiate cos s, which was t. It's giving me negative sine x. So by constant practice, you can do all this. Let's take in another one. We can take another one, another example. We have if y is equals to e to the power of sine x, the examiner asks us to find the y dx. So all these are very important because in physics we are going to talk a lot more about all this stuff. So y prime, which is the y dx, look at the logic. Function in another function, exponential function, trigonometric function. You know, this is the function, inner function is what sine x. What I will do is I will turn sine x to t. So you remember it will be e raised to power t. E raised to power anything will remain e raised to power that thing. So e raised to power t. I will never write t, I will write it as sine x. Then multiply it with, after I differentiate sine x is going to give me cos x. So this is the answer to the question, and that is very, very good. So you just need to practice more, and by constant practice, you're going to get it. We can take another example. Another one, if y is equals to 1 over sine x plus tan x, then the examiner asks us to find the y dx. Now in this case also, we can do directly because this is also two functions. We remember that 1 over here, the function y prime as the answer. Don't let me rush too much, still have time. Now 1 over sine x plus tan x. The function here we can say sine x tan x, the inner function, to be equals to t. Remember, algebra form, 1 over something will give you negative 1 over that particular function square. So this time around it will be negative 1 over t squared. We are doing direct method. So t here in this context is in this question is now sine x plus cot s plus tan x, all is squared. Then you multiply the answer with the differentiation of t, which is sine s. When you differentiate sine s, everybody knows sine s will give you cos x, and when you differentiate tan s, it will give you sec square x. So the direct answer to this can be this, or you just write negative cos x plus sec square x all over sine x plus tan x. So direct method is very important for students to practice. Please, you need to practice more this method, as it will be very, very important in solving a lot of questions when we talk about this particular topic. We can take 2 more examples so that we finish this slide to understand carefully the logic of direct method of chain rule of differentiation. So let's look at 2 more examples, like I said, to carefully understand this very, very well. So for the 2 more examples, we can look into this in the next slide to carefully understand. Still on chain rule of differentiation, the direct method, we can say in this case we have if y, let me just take two more, equals to e to the power of let's say s cubed plus 3x, then you are looking for find y prime, which is the y dx. And directly the method by now then should have understand that. So y prime will be equals to, you remember, the function up here will be the inner function. So we say e to the power of t. T is what is here. So e to the power of anything will still be e to the power of that. And t is s cubed plus 3x. And you multiply the answer by when you differentiate s cubed plus 3x, which is 3x plus 3x squared plus 3. Will be the question answer to this, and that is correct. We can take another one for understanding. If we have, very good, I think this was very, very good. If we have y is equals to tan, open bracket, e to the power of x. So in this case, we have to look for find the y dx. This is also function in function. Inner function is e raised to power x. So you know the logic. Y is equals to, we have tan t. Tan t directly from trigonometry function will give you sec square. The t now is now e raised to power x. I hope students are following. Then you multiply it by the t, which is e raised to power x. When you differentiate e raised to power x, still e raised to power x. So this will be the question answer. Maybe one more or two more to go. Still have about 4 minutes. We have if we have another one, y is equals to sec to the 4th power of x. Very good. We have a find y prime. So this method is just by constant practice. When you practice more, you're going to get it, and you understand it's very, very simple. You can say the function now. We've only talked about sec x, and sec s, from what we discussed about, we said when we differentiate it in trigonometry form, is a constant form. It's going to give us sec s tan s. Here we are having sec to the 4th power of x. So what you do here, my dear student, is just take the inner function to be sec x. So if we take the inner function to be sec s, what you have now is a t raised to power 4. So if you go for a t raised to power 4, don't make mistake, t raised to power 4 is an algebra form. So y prime direct solution will be equals to t raised to power 4 will give you 4t cubed. This is 4t cubed. Then remember, you are not going to write t. So please, you just have to be very, very careful. It should be 4, then t cubed is now sec cube of x. Then you multiply by, you differentiate sec s, which is going to give you sec x tan x will be the direct answer to the question. So when you differentiate sec raised to power 4x, your answer is 4 sec cube x, sec x tan x. So students should keep all this in mind because it's very, very important. And the last example I will take is those ones you see in your mathematics, and sometimes when you see it, you don't need to be scared because you can actually apply that method to get answer directly. So let's say we have y is equals to 4u squared plus 3u plus 5 given. Then also we are given x is equals to sine square u. The examiner asks us to find the y dx. So this is the last example I'm taking under this. I actually want to take more example because this chain rule is so important in our physics, which is the major reason why we are taking the basis of integration and differentiation. So here, to find this, what you do is just you take it one by one and you apply your chain rule as well. So here, directly, y with respect to u is the y du. Differentiate that algebraic form. This is nothing but 8u plus 3. I hope students still remember this. Then the second one, x with respect to u is the x by du. Differentiate this directly. Remember, you use your product or your chain rule. The function here is sine u. Let sine u be t. You have t squared. T squared will give you 2t. You cannot repeat t. So you have 2 sine u multiplied by. Then when you see it, differentiate sine u, you have cos u. I hope students understand this. So now this is the answer to this. But the examiner asks for the y by dx. You have the y du, you have the x du. The only way you can get the y by dx will just be by dividing the y by du divided by du by dx. I hope students understand this. This is the only way. The x by du, rather, this is the x by du, is the second function, the x by du. So this will go up, then you have your answer. So when you divide the two answers, you have 8u plus 3 divided by 2 sine u cos u will be the answer to your y prime, and that will be what the examiner asked for. So students, let me stop here for this slide. I believe when you practice more, you are going to get all these basics, because all these are still elementary when we talk about what differentiation. So in the next slide, we are going to look about some other properties and applications of differentiation, because it is also important in physics to know all this. So